Hi guys, we continue solving our task and let's check the next one that we can have. Okay, so the next one is called number of dice rolls with target sum. So what does it mean? We have n dice and each dice has k faces from 1 to k. And we are given two integers, dices, faces, and target. And we have to return the number of possible ways to roll out the dice, so the sum of three faces of the face numbers equal to target. Since the answer may be too large, we have to return model of 10, 9 plus 7. Okay. So output can be really big. For example, in this case, output would be really, really big. Okay. So what can we do here? So in our case, we can just go by every dice and then go by faces that we need to take. And so, for example, if we have one dice, we can have, let's say, k6 faces, and our target is 6. So we can get only one possible way of getting this dice. But if we have two dices, for example, right, and we have 6, then we can get, for example, 3 and 3, and given returns the number of possible ways. So I think here we can get 2 and 4, 3 and 3, 2 and 4. What else? 1 and 5. Yeah, and it's actually multiplied by 2 because we can have 5 and 1, 4, 2, and 3 and 3. So let me check this test case. So I have not one, but 2 dices, and 6, So here, actually 1, 6, and 6, 1, I can have, okay, so that's correct. That is correct. Okay. Yeah, so I believe that this question is solving with backtracking and memorization. And the question is, what should we put in memo? So with backtracking, we actually just take every dice and take how many faces we have. And we can generate, actually it can be done even with 2 loops. Not with 2 loops, but with recursion, because with loops we need like many loops. So with recursion, it's actually, with recursion we can do this. And but I believe that we need memo here, because with recursion it can be really big recursion. So imagine that we can have one dice and it has 6 options, and for every other option we can have another 6, right? So for this dice we can have 6, for this dice 6, for this dice, and for this dice. Then if we take this dice, we have already previous selected one, and we start again from 6. So actually here we have So what would be the number of such cases? So at the beginning we have like nothing, and we go 6, right? So first it would be like 6 on the 0 power, then 6 on the first power. No, it would be no. Not 0 power, so 0 power is this one. Here 6 first power, second power. So here we actually have 36 positions, and we are going again until we will get we can end maximum, we can have 30 actually, right? So we can have 30 in 30s, so it's really big number of cases that we can get. Okay, what can we do in this case? Yeah, because if we take some dice, then we take another dice, and and we are checking one by one. Yeah, do we have some hints here? Use dynamic programming. The states are how many dice are remaining and what sum total you have rolled so far. Yeah. Okay, so in some cases, we should follow up some, and if we can just return. We can just return in some cases because some will be not possible. Some would be not possible. Yeah, I think I need some help. So let's just check. All right, so we have memorization, Python explained. DP, DF target, be the number of possible dice rolls of the given parameters. As an initial example, pretend we have 5 dice with 6 faces, and we want to determine how many ways to make 18. All right, so we have 6 faces and 5 dice. So here we have 6. It would be second dice, third dice, fourth dice, and fifth dice. So it would be 2, 3, 4, 5. So it would be 6 in 5 power. 6 in power of 5. It also would be something big. At first glance, this seems difficult and overwhelming, but if we make one simple observation, we can reduce this big problem into several small sub-problems. So we have 5 dice, but let's first just look at one of these dice, say the last one. This dice can take on f equals 6 different values, so from 1 to 6, yes. So we consider what happened when we fix its value to each possible 6 case. So the last die is a 1, and the remaining 4 dice must sum to 18. Yes, that's correct. This can happen like this. The last die is 2. The remaining 4 dice must sum to 18 minus 2, equal to 16. Yeah. So yeah, so dp5 6, it would be dp4. Yeah, we sum up the solutions, these 6 cases, to arrive at our result. Of course, each of these cases branches off into 6 cases of its own, and the recursion only resolves when d equal to 0. Okay. Okay, so the general relationship, we have df dice face target, dice -1. Okay, face plus dice -1 plus face, and so on. Target, yeah, -f. Okay, so the base case occurs when d equals 0. Yeah, so actually this is correct. So we need memo. Yeah, so we need a map. Map would be integer. Integer, it's dice and target. Something like this, yes. Memo. New hash map, okay. And here we called our DP. Yes, if dice equal 0, we return. If 0 target, then yeah. If dice in memo, we return it. And to return, we have this result. Yeah. Okay, so let's call our method. We return from this method, and we should also, as was told, so it's billion plus 7. And here it will be k and target dp int n int k int target when if n equals 0, we return target equals 0, then return 1, otherwise 0. Yeah. If here it should be new int and target. If memo get this value, we just, if it's not null, we just return this value right here. Okay. Then we have our results, then we iterate from k. Yeah, from k in the range from 1 to k. So it will be int I equal 1, 1 is less or equal to k, and target, not target, but I++. And then we just add to our result this dp, and with dp we decrement our m. So k, it would be the number of our elements. We have I, it's our dice, and target minus I. And then we put in our memo, we put this thing, and target equal results, and we just return results. Let's check. Yeah, close here. Yeah, it's still limit exceeded. Okay, so maybe for Java it should be another way. Yeah, time limit exceeded. Top down DP. Okay. Okay. Okay, I think I didn't solve it, so let's leave it for now.